Hello everyone, can you hear me? Are we live yet? Probably. Anyone in the chat, can you hear us?
It'll take a while.
Yeah. Okay. Sorry, we had some last minute technical difficulties, but thanks for joining everyone. So today we're going to be testing this pressure chamber. This is a part of the Horizon project, and here's a scale model of the rocket, and what we're testing is a test pressure chamber for one of these booster segments for this two-stage rocket. Today we have George, my dad Peter, you'll see him shortly, and John, my son, he's behind the cameras and running the stream. Okay, so what we're going to do is we're going to go through the whole setup process so you can see us what equipment we're using for testing, how we set it up. We'll do a hydrostatic test, and we're actually going to do several of them. We want to be able to make sure that the pressure chamber can handle multiple pressure cycles. So please feel free to ask questions, and if we have time during the testing, we'll try and answer those as much as we can. Otherwise, we'll answer those questions after the tests. So we're going to get started, setting up the equipment, and then we're going to do the test. So we've got several different cameras set up so that you'll be able to see some details and also the test setup behind us. Okay, let's get going. So, first thing we're going to do is we are going to set up the controller that we're using for normally launching. Can you leave your house without a mask on? Yes, we can. So we've got a view. This is just a webcam. Sorry about the quality here. But this is the test setup that we've got. This is our normal launch controller that we're going to be using to actually launch the rocket. And we're using it for the test because we want to make sure all of the pressure gauges that we're looking at show exactly the same thing that we're going to be seeing during the test. We're also practicing all of the procedures in using the controller. Now, one thing we're not going to be doing is we're not going to be using, there is Peter, say hello. At the moment he's hooking up the cylinder, the high pressure hose to the controller. Then next what we're going to do is we're going to connect a high pressure hose to the back end of the controller. Help there. So this is where normally the booster would connect. There's actually 3 connections on there. 2 of them are plugged because we're only testing a single booster at this stage. David C. Is that David coming? Yeah, I think that's David. Hey, David. Okay, so let's switch this around. And what we're doing now is we're setting up, we're going to be testing it over here. So we're going to be testing the pressure chamber inside of this frame. Now, one of the things, swing this around so you guys can see. So the big difference with the booster, the booster itself actually isn't held down. So it's just got a straight through nozzle. We're not gripping the nozzle down. So one of the problems with doing the tests is this thing would just fly off. And that's why we've got it inside of that frame that's holding it steady. Okay, so because this is a a pressure test. We're actually doing a hydrostatic test, and we're going to we're going to fill this with water. So come around this side.
Maybe you should say CO2 plus something.
So we're going to completely fill it.
Do you know how many liters it is?
No idea. I think it's probably 3 or so. So the actual booster, each one of these will be about 10 litres. I think this one's probably closer to 3. So it's 2. So just don't want to overfill it too much. Almost there. Okay. How full is that bottle? Yeah, so it's about 3 litres, a bit more. Let's top it off. Okay. Now, John, you might want to get a close-up of this.
Are you sure degrees?
Oh, I'll leave it here. I'll leave it down here. So what this is just a nozzle adapter, and we'll talk about this a little bit later. This is just allows us to connect a high pressure hose during the test. Okay, so now we need some rubber bands. What we're actually going to be doing is running another experiment. Is we want to see how much the actual pressure chamber expands. We'll need the towel as well. Put those on first. So what we're going to do is we're going to put a piece of paper with markings on it that's going to be able to stretch the towel. So just going to dry it off so the paper doesn't get wet.
Okay, so let's go here.
So now we're going to put it inside of the frame and hook up. So let's stand it up. The other way. Yeah. No, put it in. No, come. Catch the end in. That's it. Now we're going to hook up the hose next.
Hold it.
Yep. So they can see. So the hoses we're using, these are Scuba high pressure hoses that are good for 3,000, they're rated to 3,000 PSI. I'm just going to bolt the end of it so that it doesn't go anywhere. And this is what stops the pressure chamber from flying off that test nozzle. Now we're going to stand it up so it's a lot easier to film. And just screw it to these blocks.
Jeremy asks what pressure you are aiming for.
So today we want to try 1,000 PSI, which is about 70 bar. Okay, move these out of the way. Okay, so let's get that piece of paper on there. And John, you can zoom in on this one.
Use just one
Just one.
on the back here.
No, they're all mixed. Too many. There we go. Just like that.
Oh, look, I think one should be
One more?
better. One on each side.
Okay.
Yeah.
So I'm not sure how zoomed in you are, John.
Yep.
So the edge of the paper's right here. So there's little gradations. So as the bottle expands, that paper should open up, and we should see more of the gradations be exposed. We'll have a camera right here in front of it, so we'll be able to see it close-up detail of that. Okay, so I think we need to raise it up a little bit. Okay. So that's all now set up. So we're almost ready to do that first test. So we're just going to rearrange some cameras here, and we'll get behind the wall. So while we're doing this test, we're actually hiding behind a stone wall in case it bursts, so that we stay safe. We're going to start up some cameras because we actually want to record this test. Just going to hit record now. Start recording. Yep. Okay. We're also recording the sound so that we can hear any creaks or pops. We'll probably hear some of those.
And how many layers of carbon fiber?
So this is 3 layers of carbon fiber. 200 GSM, and that's just straight plain weave. And then there is a biaxial sleeve, also 200 GSM over the top of that. Okay, sound is recording. We'll get this. We're recording it also from the other side on a GoPro, because what we want to see is if there's any leaks on this side, we can see where they develop.
Then we should use this stuff.
So this GoPro is recording. Okay, it's nice and stable. So we're just going to check. Yeah,
I already put it there.
we might do it as soon as we go over there, so we're not tripping.
And the
Oh,
big camera.
so let me just extend this down so we can step over it. Just going to double check the connection, make sure that there aren't any loose connectors. It all looks good. Let's start this guy up here. He's floating.
What if it takes off like a rocket? Well, that'll be interesting.
Hopefully the neighbours will return it. Well, hopefully it shouldn't take off because it's got the end frames on it. So it could come out this way or it could come out that way. The ideal situation for us is nothing happens. It just sits there all by itself. Okay, so is that camera? That's fine. Let's make sure we've got enough light in there. Okay, so those cameras are rolling. This one's rolling. Yep. Yeah, we'll angle those down a little bit. So you guys will be able to see the pressure gauges and also the pressure chamber while we do this test.
And
Okay, so let's zoom in on the actual pressure chamber. A bit more. Maybe angle it up a little bit just so it's just above the... Is there enough light?
That's
Okay.
looking good.
Okay, I think we are ready to do the test, so we're going to go retreat. Into the safe zone. And are you able to then switch between your safety goggles? Are you able to go switch between the GoPro view as well?
So, what did you want?
So the gauges and GoPro view, and also to be able to then switch to the other view.
Yeah.
Yeah. So we're just going to set up one more camera that's going to film the gauges at this end. Just going to put this over here. Okay, so we're ready for... So anyone listening with headphones, if this goes, it might be a bit loud. All right, so what we're going to do first is we're going to put in about 50 psi, and then we'll just have a quick check to see if there are any leaks. But after the 50 psi, then we'll definitely retreat. So
Okay.
wait, we've got yes closed. Yep.
Starting.
Yep. Cool. Okay, stop. So one of the problems is because it's full of water, the volume inside of this thing is so small where the air pressurizes that even letting a tiny bit of air in, the pressure climbs really quickly. So at the moment we're sitting at about 250. Just double check. I don't see any leaks. I don't hear any noise. Okay, so we're going to continue the test.
Just keep it on the camera.
Yeah, let's just keep rolling the actual. Was that us? Okay. Oh, it's the turkey. We should show that. Nah, it was a bush turkey that landed on the fence. Okay.
300.
Yeah, so we're climbing up in pressure. The other thing we're going to do is when we hold it there, we're going to hold it for 3 minutes. So we've got it.
400.
So we're listening for noise now.
500.
We can switch to views.
6.
Keep it like the chat.
Sorry guys, if you guys are asking any questions, we'll answer them after this
700.
test.
$800.
Still good.
900.
So we're going really slow.
And 50. $1,000.
Okay, air's off. And timer started. So now we're going to wait for 3 minutes because, so I can see we've got a bit of a leak at the nozzle end. There's a few drips coming out. I'm not sure if you guys can see that. That could be maybe dirt on the O-ring. It could be a leak between the fiberglass. That's still okay.
Yep.
We are still just below 1,000 at 30 seconds.
Can you hear some slight hissing?
Yep. Oh. Yeah, I think there's a leak maybe.
Yeah, I can hear it.
We can hear something here. So 50 seconds now. Oh,
960.
the noise, there's a blue tongue lizard. I gotta show you this, guys. Oh, the hissing we heard was actually a blue tongue lizard.
Where is
Oh, he's climbed over there.
Have a whole zoo here.
He knew what was coming. That's weird. You guys can still hear. Yeah, that's the blue tongue lizard. So we're at 1.5 minutes. We still have that slow drip. Still going. So the pressure's now dropped to just over 900. That could be a result of that slow drip.
it's about 940.
So we're almost at 2 minutes. Still holding. So 2 minutes now. So even with a slow drip like that, that would still be okay for the launch. You would only lose a few mil. There's about 3 litres of water in each of the big boosters.
It's
Two.
910.
So pressure's dropped a little bit, but no obvious leaks yet.
900.
And what's that noise that I'm hearing right now? Yeah, that's...
That could be
Air.
that could be just where the leak is. Okay, we're coming up to 3 minutes, so we're gonna. Is the air still on? Oh, no, that's closed,
It's
isn't it?
close.
Okay.
But I can increase it to
Okay, so we're at 3 minutes now, so we're going to stop the test. So that's 3 minutes is up. So air is off, so we're going to depressurize, and we'll show you how we're doing that. We're doing that remotely. Can you go to, I think this view. So here's the pressure release. Not sure you can see that pressure's dropping. Now, pressure stopped, that's because it's trying to force water through really tiny holes. So it's still depressurizing. And we'll soon get water coming out. Oh, it's pouring straight on the drill. Okay. So this is water.
80 now.
So this is water just pouring out of the back of the controller. That's expected. It drains underneath. So normally this controller sits out by the rocket. I'm going to make sure I'm pointing it where it's supposed to. So far that was a fairly successful test. Although we had a small leak in around the nozzle, the pressure held. So maybe let's have a look at some of your questions before we start the next test. We're going to have to refill some of that water back into the pressure chamber. So let's switch over maybe the GoPro view, see what we're doing. Okay, so what was I going to have a look at questions? Morning. Yeah, so that was about 70 bar. That was inside of that pressure chamber. It's still depressurizing, so we're going to let it finish all the way. I'm going to switch over to this one. It's not focused. There we go. Still lots of water coming out. There's just really tiny holes in the hose, so if it has to force the water through them, it just takes a while. So that's why we're not taking the pressure chamber off the end of the hose yet. There's still a little bit of pressure in it. Derek asks, Derek, the metal frame is taking all the pressure that the nozzle's exerting onto the frame, and that's about 120 kilos is what's pushing Can you switch to this view, John? Or the other camera? Actually, let me stop these guys. Sorry, just got to stop some cameras here. When it's under pressure at the full 1000 psi, there's about 120 kilos that's pushing onto this point. That's how much force is the pressure chamber trying to get off that nozzle. So yeah, about 120. We should keep going to see how much it really can hold. That is the intention, what we'll do eventually. So our next test is going to be identical to what we just did. Again, we want to test the pressure chamber under a pressure cycle because something might have loosened. Something might have loosened on the last test, and when it relaxes, things could break, so we'll repressurize it again. So Peter's going to, we're going to demount it now and refill it with water and run that test again. How much flex was there? We don't know yet. We're going to have to review the video camera. I expect it's probably going to be a couple of millimeters that it increases in diameter.
Where is spanner?
Pierre Rabbit asks whether these tests have water in the pressure chamber. So when the rocket launches, it will have be third full of water and the rest is going to be air. So we're not testing any air in these pressure chambers. Now, air does heat up when you compress it. And so what's going to happen is it's going to...
Another one.
oh, sorry, we'll just need some extra tools. It's just stuck. Yeah, so what's going to happen is the pressure chamber is going to heat up when we pressurize it with air and water. So one of the ways to get around that is we have to fill it slower, and that allows the pressure chamber to cool as it's being filled. And what we also do is we fill it in bursts. So we'll put in maybe 100, 200 psi, and then wait maybe 30 seconds, let it cool down a little bit, and then we continue pressurizing it.
No,
Do you need help?
didn't catch. No.
I'll get another tool. Always technical difficulties. Okay.
What it from there?
I think we loosened the other one before. That's why this one was tight.
Jeremy asks, how high are you hoping for when it launches?
That's a really good question. We're hoping over 1 kilometer. Okay, so let me just hold this. Okay, so let me disconnect the hose.
Need a ring spanner socket set.
Alright. So, do we want to take the paper off before we spill water on it?
Oh, probably. But it's probably not necessary to use it again.
So we're going to refill it again because not just the water that came out while it was leaking, but when it's lying sideways, the air sits at the top of the pressure chamber, and when we're depressurizing it, the air's pushing all of that water back out through the hose. Oops. Slow, slow. So yeah, it takes about 3 litres this pressure chamber. So we'll have a look at the video closer to see where it leaked around the nozzle, whether it was past the O-rings or whether it was through the actual pressure chamber itself. Okay, very full. There's a bit of air. That's okay. Maybe let's top it off. Let's really top it off. Okay. Should get a nice little fountain. Let's put it back in the frame. Come around the other side so they can see. No, co jeszcze tu końcówki?
Which one?
The little one. The little. We can put it on the side now. Okay, let's screw this down again. Are there any more questions, John?
Yeah, a few more.
Can you read them out?
Alright, we have, how are the quick releasers going to hold that pressure, that much pressure on the horizon booster sections? Will it be similar to the sustainer stage releaser? That's from AR.
Okay, so where are we at? Ooh, which one are we pointing at? No, the camera.
Oh, what was the question asked?
Huh? I heard the question.
Okay.
So this is the actual hold down mechanism. Which camera are we on? The GoPro? Okay, so this is the actual release mechanism that's going to hold down the entire rocket. So we've already got a video out about this, but this is basically the mechanism in the center of the rocket between the 3 boosters that plugs into here. And then these 2 massive levers are actually what hold the entire rocket down. So that's the release mechanism. Okay, back to the test.
We've got a few more questions.
Okay, let's have a look at the...
George, come in.
Oh, okay.
I cannot put the screw in.
There we go. We took out this one last time. I think that's why this one was more difficult. Okay, I'll see if I can answer some more questions. Old Mate Battle asks, wouldn't the air cool as it goes from the filling bottle to the rocket? It does, however it picks up heat in the hose again, and then when it goes inside of the pressure chamber and compresses, it heats up again. We've tried bubbling the air through water to see if we could cool it down, and made no difference. The air still compressed above the water and heated up. So he also asked, what size nozzle will you be using? I believe these are 19mm nozzles in each of the boosters segments, so it's 3 times 19mm. The valves on my compressor get hot when filling. Yep, that's compressed air. How many years have we been building water rockets? I think this is our 15th or 16th year, something like that. how many layers of carbon fiber wrapped to make the pressure chamber. So here's a cross section. So these are the previous pressure chambers. I'm not sure if we'll get a detail. John's just resetting up there. So you can see that's the cross section of this pressure chamber. It's got 2 layers of 200 GSM carbon fiber cloth on the inside, and then it's wrapped with a biaxial sleeve that's also about 200 GSM. So it's really 3 layers of carbon fiber. The wall thickness, I believe, is around 1.1 mil or something like that, around a millimeter. Okay, what else have we got? Okay, well, let's continue with the test. So, do you need help?
No.
Do we want to do the paper again?
No.
Not this time, okay. But we will dry the pressure chamber because we want to see if there's any leaks. We'll leave those on, that's fine.
How important is it to have the smooth interior walls?
So what we do is we coat the inside walls with a couple of layers of epoxy just to make sure that they're sealed. A smoothness really doesn't matter that much, but we do coat them to make sure that there's not little micro pores within the pressure chamber. Let's repoint this camera. Okay. We'll put this guy back further this time to film the whole pressure chamber. GoPro set up.
Maybe directionally where was the leak last time?
And I think the whole frame is skewed as well.
So how much will the tank weigh empty?
Dad, I think we've got the frame skewed. We'll need to fix that.
10 kilos.
Sorry, how much will
How much does the tank weigh empty?
this particular one? I don't know. We haven't weighed it. But we can certainly weigh it after the test.
2,000? That might be pushing it.
2,000 kilos?
No. PSI, I assume.
Yeah, everyone wants to see more pressure. Dad, we have to fix the frame is skewed. We can't have it skewed for the test. Where's the spanners?
Would,
Yeah, it's just important to make sure that, because if the frame's skewed a little bit, what can happen is that the top of the pressure chamber doesn't sit flat at the top, and it could put an uneven load on the pressure chamber. So we're just going to fix this up. So we've got a little bit of wood at the very top of it, and that's supposed to help spread the load a little bit.
do you need any help?
Yeah. See how it's at an angle? Can we just pull the top of it this way? No, we have to loosen it. Sorry guys, but if we want to do the test properly rather than quickly.
Yeah, it's already moved. No, it will be too much.
No, I think that looks good. Bit more, bit more.
Okay, it's moved.
Okay, I think that's good.
Damon asks, do you run any computer simulations to assist in designing the composite layout?
We do not. It's all trial and error. That is also why we're on our third pressure chamber. With simulations, there's an ideal way to wrap the pressure chamber, but it can never mimic exactly what we end up doing with it. Maybe we don't have the epoxy ratio quite right, or maybe the tension slightly different. So we find doing the actual pressure tests are a lot more useful. So we don't know what the upper limit is of this pressure chamber. We expect maybe 1500, the actual burst pressure. I'm not talking about leaks. But yeah, so maybe around 1500 psi. Do you need help?
Because I cannot see it.
Okay. So let's get this camera rolling again. So the reason we're running this camera back here is if a leak develops on the back side, that we'll be able to see what actually happened.
Georgian, direct it to this one.
Okay, we'll focus the little camera onto where the leak actually was, so we can inspect that later on in the video. Okay, so let's set up the pressure gauge camera again. Okay, does that look about right? Am I still recording on this other camera? Yep. That'll need to go a little bit further over. Okay. So we're going to start the test yet again. Is this still recording? Yep, that's still recording.
I don't know.
Just try and get a detail. Okay. Camera's rolling, camera's rolling. That's all screwed in. Yep.
Do you think you'd go with a light-colored paint job on the final Horizon rocket
Yes,
to
definitely.
avoid it from heating up?
Yeah, definitely. The rockets probably end up being white again, like the Sustainer. We did some earlier thermal tests of how much the pressure chambers heat up in the sun, and white was by far the easiest.
What about silver? We should try silver.
We could try silver as well to see if we can reflect some of that heat. And Wojtek asks, do you plan to use a DeLaval nozzle or a CD nozzle to make the air burst more efficient? For this rocket, no. We're using just straight through nozzles both for the booster and for the Sustainer. There is a possibility for the Sustainer, because it uses foam, that a DeLaval nozzle or a convergent divergent nozzles would give some benefit, but that's a future research project. Anything else? Chrome it. Yeah, that will look pretty cool. All right, I think we're going to start the test again. So we're going to go retreat to, I'll reset the timer. The camera's recording. Swap to that one. Yep. All right, let's get over here. Just going to stop it and so restart it so that I know which one it is. Okay, so still going. Okay.
So I will try about if you want
What?
that only.
Oh, we forgot to close the pressure release valve, so we're just closing that. All right, that's all closed. what, we can't pressurize it with the pressure release valve released.
We can.
And thank you very much, Flight Industries, for the donation. Just wait. Did you consider wrapping the carbon fabric under tension during fabrication to increase strength? Yes, ideally we would want to wrap it with a wrapping machine. However, we do not have the equipment to do that. So, but yes, that would definitely help.
So I'll go ahead and chuck it because it's only 250.
Okay. So we're at 250 psi again, and we're just doing a quick check
Actually 150.
to see if there's any. See my backside there. See if there are any obvious drips or leaks or discoloration in the pressure chamber. Now I think we're all good. All of the. All right. So let's start the test. So this is test number 2. We're going to go to 1000 psi again, or as close to it as we can get. So we're probably expecting a leak around that nozzle again. So pressure
300.
slowly rising. So I think the last pressure chamber was around 900 psi when it leaked on the second pressurization test. So we changed.
500.
So we changed the construction technique a little bit to try and resolve that situation.
600.
So we've got that leak around the nozzle again.
7. 8.
I'm backing away.
Nearly 900.
900. And
I will go a little bit higher.
okay. Let's go just a little bit above
900.
1000.
1020.
1020. Okay, so we're starting the timer. So we're going to hold it there again for 3 minutes. So what we've done is we've closed off the air to the pressure chamber. So any pressure drop that happens now could be for a number of reasons. Water leaking out, pressure chamber expanding, and also any air that's in there cooling off. So that's why we went a little bit over 1000. I think I just heard it pop.
You hear the faintest hiss of sound of air.
So it's still holding. We're at 40 seconds now. So, like I said before, if we had a nozzle leak like this on the actual launch day, we would still go ahead and launch. The rocket's still holding, would be holding pressure hopefully, and the few mils of water that it loses shouldn't affect anything.
It's still over 1000.
So we're still holding at 1000 psi and 1 minute and 10 seconds. So this has held up longer than the previous one, which failed after 15 seconds on the second pressure test.
It's about 960.
So, yep, pressure's now dropped to 960 as you
So
can
do
see.
you know what? I will increase it to 1000.
Okay, we're just going to put in a little bit more air just to compensate for that pressure drop. We're at 1 minute 40 seconds. Now, one of the reasons we have to hold the pressure in there long enough is if we're at the launch site and we pressurize the rocket.
1000 again.
So if we pressurize the rocket and we need to hold for whatever reason, if the range is not safe, the rocket has to be stable enough to be able to handle that pressure. So we're at 2 minutes and 10 seconds. Still got a steady drip.
It's still 1000.
Okay, so we've refilled it and it looks like it's now holding, so that initial pressure drop looks like hasn't continued. So almost 2.5 minutes. And then John, when we depressurize, can you turn the camera off? So still holding 1,000. So this is looking good so far. Still no noise. Didn't hear any creaking this time, did we? So we're approaching 3 minutes now. So we're getting ready. So air is off.
Yeah.
Okay, so we're at 3 minutes. So we're going to depressurize. So I'm going to show you the view from inside how we depressurize it. With the pressure on well. So that's just the air in the hose. And shortly we'll get water coming out as well. So we're at almost 0 psi over here. But there's probably still maybe 20 psi in the line, so we have to wait until that clears before we disconnect it. So that's just the water coming out. Alright, let's put John back in charge. Because I can't point the camera. Okay, thank you. Wow, very generous. Flight Industries again. Thank you for the donation. If you ever need anything intricate machined in any material, I'm a CNC programmer, machinist for a tech company here in California. I'd be happy to do it at no cost, although it would take some time to ship it. Very generous offer, Flight Industries. We may take you up on that if we're trying to build something. Thank you very much for that offer. Drew Bradley asks, I wonder if attaching strain gauges and wrecking one of the, sorry, grab my glasses here. And wrecking one on purpose via overpressure will allow you to predict failure point in the future vessels. That's actually what we do intend to do. We do want to basically burst test it at some point. There's still a few other tests we would like to do with it first. Acumelon asks, what flight computer will Horizon use? We haven't finalized it. The Sustainer's probably going to use. Get one to hold it. It's probably not a hole to see here. We're probably going to go with a Stratologger for the Stratologger CF for the Sustainer. We're also thinking about adding a GPS unit, because one of the issues we had is it went too high and we lost sight of it. So the Horizon's not, the booster's not going to need it, but the Sustainer might. We haven't finalized what flight computers we'll use on the booster, although there will be 2 redundant systems on it with 2 separate parachutes. That's the plan. And NM Rocketry, that's New Mexico Rocketry, I believe. If you want a custom FC design, let us know. I'd be happy to design one for free. Thanks for that offer. Yeah, we like I said, we haven't decided yet what we're going to do on the booster itself. Cool. Okay. So let's point the camera back here. We're going to run a third test. We're going to do that one more time. So far so good. Let me just turn the cameras off. It's off. Stop this one. So one of the things we will do is after this stream, we'll put together an edited video that shows the construction of this pressure chamber and what changes we made over the previous version. Go over here. And then we'll also include some of the footage from these tests. That's why we're kind of running around turning on other cameras as well. All right, I think we can disconnect the... Okay. I think that should be sufficient pressure drop in this line now.
But there is difficult.
Oh, that's why. We can unscrew it from the wood. Do you want to do that?
Yeah. No. It's already books.
I can lift it up if that's easier to access. Sisters of it. Okay, so let's put this in. So let's refill it a third time. So one of the things we do is we inspect it. If there's water leaking into the walls, it'll actually go a milky color, and I'm not seeing that here. So that's good. Okay, so I think it needs probably another liter again. And then after this test, I'll explain some of the changes we made over the previous one. Okay, we are full. Yep, top it off, please. I'm going to take the rubber bands off because maybe they were holding in the pressure.
Definitely.
Okay, let's put that guy back again. Zase běž tak, aby Počkej, stop. Okay. Dej to, musíš to dát, než se to položí. Nejde rovně. We just got to get the hose on before we put it down, otherwise the water will drip out. Nemáš to rovně. Okay, let's put it down. And Johnny, if people asking questions, could you read them out, please?
Yep. Kevin says there are some paints that are actually IR reflective, but they seem to be mostly house paints. You couldn't find any lacquers, unfortunately.
Interesting.
In case you get heat issues on the pad. That's an interesting point.
Yeah. House color, like a beige Farina or something. Let's dry it off again, just so that we can see any drips.
I take it that the valve box sits out in the ground near the rocket rather than by the operator station.
That is correct. So there's a really short hose. We've actually got a much longer hose on it at the moment. So for the actual launch, that box sits right next to the rocket. Okay, that's all set up. It's we're still recording, so let's do third test. Let's hope this holds. Start up this little guy as well. Dad, I might put the camera on the other side to see if there's if the leak is more visible from the other side here.
Alex says, is this a off-the-shelf project?
Off the shelf? No. Definitely scratch built. Okay, that's recording, that's recording. Do we still have this camera recording? Yep. Still pointing at it. Perfect. Okay. Alright, we're going to get back into our cubby hole. Just going to rearrange the camera here for the pressure gauges again. Not seeing it. Down?
Yeah, you can see it there.
Ah, yep. Okay. Pressure release valve is closed.
Got a couple more.
Okay. In terms of, so Arrow asks, in terms of the regulation of these high power water rockets, do they take your word on the simulation on the total impulse of the rocket for where you can launch it? Not sure. Yeah, you might have to provide some kind of evidence of the pressure test. Because these aren't commercial, you're really self-certifying the pressure vessel yourself. And Acumelon, I hope I'm pronouncing that correctly, will there be any onboard cameras on Horizon? And if they do, will it be the Mobius Mini 2? Yes, that is the intention. So the Sustainer is going to have one camera looking down at perhaps a 40-degree angle, and the booster is going to have two cameras, one looking up at the Sustainer and another one looking down at the ground. So 3 cameras in all for the entire project. Okay, so let's start that last test, and then we'll explain a little bit about the pressure chamber. All right, let's do it. Oh yeah, we'll turn this camera over this way. And you can probably toggle between those as well while we start the test. So the pressure gauge, and I'll stand over there. Reset. Okay. We'll set up the camera here. So we're just setting up for the test.
Okay, it's 200.
Just
If
press
you
the
want to
0
check
when you
it,
want to swap it.
So, was it on us?
Yeah, it's on the screen.
I just switched it. Oh, that's switching the pressure gauges though.
do you want to check it?
Yeah, I'll just have a quick check again while it's still low enough. Standing right in front of the camera, right?
It's perfect.
Yeah, I'm just checking if the end hose connection is well sealed. Yeah, it's looking good. Okay, let's go to full pressure. What are we watching? We're watching the...
If you want to watch us,
Yeah.
it's 4 or 5.
Okay,
Try 4.
I did 5? Yeah, so this one.
Very good.
And
300.
do I need to transition?
Yeah, 0 to transition.
And then 0 to transition back to the other view?
Yeah.
Okay. Okay, so we are at 400?
Yeah.
Oh, haven't started the timer yet. So anyone who joined us late, this is the 3rd test of this pressure chamber. It's had 2 cycles to 1000 psi, and
600.
it's held there for 3 minutes for each cycle.
You'll want to swap it.
So back into the camera, back into the view.
800.
So that drip is remaining a bit fairly constant. So we're at 900. We're listening for any pops or creaks, fibers breaking as well.
So it's 1000, but I am going a little bit higher.
So we're just pushing it up above 1000. Okay, I'm starting the timer. So we're at 1150.
1050.
Hearing some.
Yeah, we're definitely hearing creaks. There's definitely creaks, so we just want to stand back at this point.
But hold the pressure.
It's still holding.
Yeah.
So it may be some fibers are breaking or settling. There are a couple of thin layers of 85 GSM fiberglass, so that's maybe what we're hearing rather than the carbon fiber.
Still above 1000.
There is definite discoloration on the pressure chamber itself. At the top of it, top.
Did you hear it?
I can see that there's definitely something there. There's definitely some side effect of this pressure cycle. It's holding still.
There is 1000.
Yeah, we're definitely seeing there's something has happened to the pressure chamber. Again, if this was on launch day, we would still probably go ahead and launch because
it's
we couldn't see it.
still 1000.
So we're at 1.5 minutes now.
The creaking stopped.
Yeah, creaking stopped. Everything that was going to break has broken, except for now. No, now. So still holding, still dripping. Because when we build the final boosters, we're going to have to test them to full pressure as well, and so it's going to go through several cycles, and that's kind of the reason why we're doing these tests. So we're at 2 minutes and 10 seconds.
It's about 970.
So it's still holding pressure. Good. Still going. And 3, 2, 1, launch. No, wait. Okay, 2.5 minutes. Grandpa, I'm going to leave the camera on there. Grandpa's praying, please stay. Please don't burst. So we're almost there. So
8, 7, 6, 4. Oh, well. Now.
okay, 3 minutes, and we're depressurizing. Okay, so that is a good test. So we're pretty close to zero now, zero pressure, so it's safe to approach again. And what I thought I saw, that's fine. That was just the small rat.
There was.
Yeah, no, it's probably.
There was.
No, I don't know where the leak
Okay.
was. I thought this is. Sorry.
More than just fall.
John, can you just zoom in on this section?
You must turn the camera the other direction.
Oh, let's turn this one around as well. Yeah, what I thought I saw that there was definitely something there. This is what I saw, but it's just a reflection of the light. There's an overwrap of a bit of fiberglass over the top, and it's just the rough edge that I saw. So pressure chamber is intact. It's still under quite a bit of pressure. So we're just going to let that depressurize. Maybe let's answer some questions that came up. Where did we get to? Oh yeah. Yeah, definitely use a lighter colour coat for the final paint job. The gap between the seat and the nozzle. Yeah, so what happens is when we pressurize it, this gap will open up because there's nothing holding the rocket down. So this gap will get bigger when we pressurize it. That's normal. It doesn't like the over 1000 psi thing. No, it was quite happy holding the 1000 psi. The pressure chamber diameter is 80 millimeters, and the length show you the length. I'll probably have to get back a little bit further. So this is the inner liner of the actual pressure chamber for the booster. So we've got 3 of these, but that's the full length of the pressure chamber, plus the end caps at either end. There will be an extension on top where the parachute sits and the nose cone, so it will be maybe about this much longer overall. So yeah, that's how long it is. Just over 2 meters. Okay, next question. How much of an overpressure tolerance do you test to? So we will test it to probably 1500 psi, just to have that, I guess, 30% safety margin. Jason, yes, around that, around 150%. Derek asks, does your dad ever wear his World War II helmet for pressure tests? He actually mentioned it before doing this test that we should have our helmets on. It's just for the launches, however. Thanks, Spirit Rabbit. Thanks. Testing the chamber, all while entertaining the audiences. Okay, thanks, guys. So I believe these tests have been successful. I think we're holding. I'm just getting shot here. Take these off. So I believe these were successful tests. The fixes we did to the pressure chamber look like they've worked. We will still do an upper sort of pressure test to see how much it'll actually hold over the top of this pressure. However, the next test we're going to do is really important because, let's take this off so I can explain it. What's going to happen is the actual booster isn't held by the top like this has been. So the whole thing is going to stretch lengthways. The frame is holding it in place, but that's not how it's going to be on the actual booster. So I'll explain that as soon as we get this off. Got it? Okay. So, sorry, I'm just going to drain the water out of it.
Okay, over these.
Oh yes, thank you. That one's run out of charge. I can stop this as well. Okay, so on the actual rocket, the entire booster. Sorry, John, I can't see what's on the field. So the entire booster is held down by this central point. This is the release mechanism. This is the release mechanism that's holding everything down. There's nothing holding the top of the booster down like we saw in this test. So the next test we're going to do is, here is a 3D print, just a mock-up of that central staging mechanism, or central release mechanism that mounts between the boosters like this. I'll show you. So that sits between the middle. And this is what actually, this structure is what's actually going to be holding down the entire rocket. So what we're going to do is use our prototype. We're going to attach this to the side of the rocket. And we're going to do, I'm not sure if that's easier to see. And we're going to mount this on the side of the frame and not hold the top of the booster down. So we want to see what kind of loads at 1000 psi are being put onto this. And how we're going to mount it. So that's kind of the next test, is this framework that we're planning on putting here, is it going to be able to hold the entire rocket down, or is it going to rip the booster off? So that's the next test. If it passes this test, then we're going to overpressure this to maybe the 1500 psi to see if it'll still hold or what's going to happen.
Flight Industries, thank you for the $5. Will you be doing a maximum pressure burst test on this test chamber?
Yes. So, like I said, the next test will be while we attach the thing to the side, and if that holds, then we'll do the overpressure test. We just don't want to be building another one of these. So yeah.
The fuel's quite green.
Yeah, and you can drink it too. What else have we got? Water rocket space race. Air Command versus Arca Space. I think Arca had a setback, didn't they, with regulators that they weren't allowed to launch, I think. What is the estimated weight of the final rocket? That's a really good question. The Sustainer, I believe, weighs about 1.5 kilos, so this is dry weight. So this is without any water in it. The booster's probably going to come in, I would say, probably closer to 4 kilos dry, 3.5, 4, something like that. We don't actually know yet. But someone did ask how much this weighs, so we can weigh. We've got a scale here, so let's weigh it. And he's back with the scale. So let's turn it on. So this isn't really indicative of the length of the entire chamber because the ends are heavy. This thing weighs 440 grams. But when you stretch it, it's not proportional because the end caps are quite heavy. So I would expect the full pressure chamber to weigh probably closer to 1 kilo each. And then we're going to have parachutes and nose cones and fins on top of that. Yeah, so we're probably looking closer to 4 kilos for the booster. There's going to be about, I think, 10 litres of water in it. The Sustainer will have, I think, 1.5 litres of water in it. So all up, when it's fully fueled and heading off the pad, it's probably going to be, what's that, 10, 14, yeah, we're probably pushing 16 or 17 kilos when it takes off.
Do you know what the equivalent impulse motor would be?
I do. I should have written this down. I'll have to get back to you. I've got the number somewhere. Yeah, somewhere in the J category. Sorry, just reading the next question here. So Acumelon again asks, even though the channel is called Air Command Water Rockets, do you have any plans going into solid fueled rocketry or high power rocketry? So yeah, we do fly solid fuel. We're level 1 certified. We do plan on getting level 2 certified before flying this Horizon rocket. So yes, definitely all forms of propulsion are good with us. Cool. Okay. So a little bit about the pressure chamber, what we did to fix it. So what we did with the previous pressure chamber is we cut it up into little bits.
First assistant.
Thank you. Hold this. So what we did is we cut the pressure chamber in half so that we could inspect where it might have been leaking from. And although the... yeah, I think it was this one. Not this one. One of these.
Order.
Oh yeah, we cut this one in half. Okay. So we thought it was leaking through the side wall because on the other side where the
Close up over.
the water was leaking out through the wall here, and so we thought, oh, maybe it's just come through a micro hole. But when we checked on the other side, it was perfectly smooth. But one thing we noticed was what was happening is the leak was coming through that bit of tape. Sorry. Yeah, so here's a good example. This is the one I was looking for. Perfect example. So we thought that it was coming in through the wall, but what was happening is there's a tape here that we used to hold down the initial carbon fiber layer, and that extended underneath the overlap, and then water would come out under here and re-emerge through the sidewall. And so what we did with this pressure chamber, we just stopped the tape short of that overlap. It just wasn't needed in there. And I think that solved the issue, that leak issue we had with the last one. So it was just purely the tape that was holding that initial layer of carbon fiber in place. But yeah, nothing came through the walls themselves. So this was the original one. So you can see the original one was a little bit rougher. And then on the subsequent one, we gave it a thicker coat of the epoxy, and that's all nice and smooth, and no water actually made its way through that. So yeah, so that was the difference between this and the previous one. Wow, Flight Industries, thank you again for the donation. That's really generous. Do you use plain weave carbon fabric throughout the entire chamber, or do you also use some unidirectional or satin weave fabric? So for the inner two layers, and that's what this is. These are the two inner layers of the pressure chamber. This is just plain weave 200 GSM carbon fiber cloth. It has a single layer of 85 GSM cloth on the very, very inside. So this is plain weave cloth, and then on the outside we've got a biaxial sleeve that wraps the entire rocket, so even over the end caps, just to hold everything together. So no, we're not using unidirectional or any other type of weave. What else have we got here? Would be cool to do a video where you compare solid fuel rockets and water rockets. I think you did that video, didn't you, Arrow? I thought someone did. We have a rocket, actually the rocket that's hanging back here, right there. This is called Light Shadow. This was our level 1 certification rocket. This is both a water rocket as well as a solid fuel rocket. So we flew this on an H motor to get our level 1 certification, but to test all of the systems we first flew it as a water rocket. So that's probably a good way to compare solid and water rockets, because everything else is the same other than the pressure change, other than the propulsion.
And price.
And price, yeah. So anything else that we wanted to discuss? Yeah, I think that's probably it. So the next steps will be to actually start building the booster, now that we know how we're going to build those pressure chambers, and do the test with the release mechanism mount on the side of it. So yeah, I think we can probably finish up the string here. It's time to go. Yeah, so unless anyone else has any other questions, we're going to finish this up, and we'll publish all of these results and the tests in an edited video that shows us constructing the pressure chamber again. So thanks everyone for joining in. It's been fun. We had a last minute a hiccup with the stream like 2 minutes before it didn't want to start streaming, so it's all good though. So, yep, thanks again, and we'll see you next time.